Hello and welcome back to another video on my YouTube. Today we're going to be attempting this Cambridge STEP warm-up question that is found on the modules on their website. So the first bit is quite simple. We have to expand and simplify 1 plus root 2 all squared. So 1 times 1 is 1, root 2 times 1 twice is 2 root 2, and root 2 times root 2 is 2. Collecting all the like terms together, we get 3 plus 2 root 2. You may be wondering why this is even part of the question, but it will become more clear later on. So let's move on to part B, considering part A was a bit too easy. We have to find all the real values of x that satisfy x squared plus 4 over x squared is equal to 12. And we have to leave our answers in third forms. What immediately strikes me is the x squared as the denominator, and we have to try and remove this. My initial thought was to multiply every term in the equation by x squared, and this leaves us with x power 4 plus 4, because the x squared has been removed from the denominator, is equal to 12x squared. Now we've got to solve and simplify this quartic equation. But how do we go about this? We'll start by moving everything to the left hand side to become in a more conventional form. And if you didn't spot already, there's a hidden quadratic in this quartic. We will let everything which has an x squared be equal to y. X to the power 4 has 2x squared, so we can consider it as y squared. 12x squared has 1x squared. So we'll do take away 12y, and 4 has nothing, so we'll just leave it as it is. Normally, I would factorize this quadratic, but considering the splitting the middle term method doesn't work here, because nothing can multiply to get 4 and add to make minus 12, we will have to use the quadratic formula, which is y is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. I've quickly put the values into the formula, and you can see this on the screen here. And once we simplify the root 128, which we get, we'll eventually get everything over 2, and this is equal to 6 plus minus 4 root 2. It is really important not to forget the plus minus in this equation, because instead of getting 2 solutions at the end, we'll get 4 instead. Now y is equal to 6 plus minus 4 root 2. If we factor out a factor of 2, we're left with 3 plus 2 root 2, all multiplied by 2, is equal to y. But remember from earlier on that x squared is equal to y, so replace the x squared with the y. When we have a plus minus, the equation can be written as one of two ways. 3 plus 2 root 2 or 3 minus 2 root 2, and this is why part A was so crucial to this equation. Remember from earlier on that 3 plus 2 root 2 is actually equal to 1 plus root 2 all squared. We didn't have this earlier on, but 1 minus root 2 all squared is actually equal to 3 minus 2 root 2. What we do now is replace what we had in the previous equation with the factorized form. So we've replaced 3 plus 2 root 2 with 1 plus root 2 squared, and 3 minus 2 root 2 with 1 minus 2 root 2 all squared. And so we can revert back to the plus minus symbol, because they are essentially the same thing, except one has a plus and one has a minus. So as a whole, x is equal to 2 multiplied by 1 plus minus root 2 all squared. So this is where it gets a little bit tricky. To solve for x, we need to root the whole equation. So as I've done here, we get x is equal to plus minus, because when you root something, it could either be its positive form or its negative form, the root of 2 multiplied by 1 plus minus root 2 all squared. But now there's a square inside of root, so they essentially cancel out. And only the 2, which is the multiplier, is left within the root. So x is equal to plus minus root 2 multiplied by 1 plus minus root 2, and the 1 plus minus root 2 is outside the root because the squares have cancelled out. And there we have it. Once we expand the brackets with the root 2 multiplying by the 1 and the root 2 again, we're left with x is equal to plus minus root 2 plus minus 2. And this gives us 4 solutions because there's 4 different ways we can form this x value. As it said, leave the value in third form at the beginning. We'll leave the answer as it is. So thank you for watching this video today. This is my first video on the Cambridge type step questions, so please leave a like and subscribe if you'd like to see more. Anyway, thank you for watching and I'll see you next time.